Okay, welcome back, and now we're going to talk about integrals that result in inverse functions. Okay, so these are ones, again, at this point you're going to have to memorize them, you're going to have to know them, but later on we're going to derive these in Calc 2. So you'll be able to derive these using Trig. Okay, so and using the unit circle, the right triangle, and such. Okay, so but right now we're going to do a proof of one of these in the next video. But again, these are three of the integrals that result in inverse trigonometric functions. So the first one is this one. If you have anything of this form, where you have du over the square root of a squared minus u squared, where u squared is a function, right, a function of x, and a is any constant. Okay. Here, this is the integral, so that'll result, this one will result in sine inverse of u divided by the absolute value of a, plus c. Okay. Now, number two is anything of the form of 1 over a squared plus u squared, right? So this is of the form 1 over a squared minus u squared. This one is of the form 1 over a squared plus u squared. This one is of the form of 1 over u times the square root of u squared plus a squared. Notice that in all three of these, you can't do a u substitution because there's no u in the numerator to be part of your du. Okay? And so in this case, you can't use u substitution. So that's the kind of the, what's the word I'm looking for? The limitation of the u substitution. You really can't use it for everything. But again, in Calc 2, you'll learn other techniques of integration, like integration by parts, and using partial fractions and things like that that can help integrate more complicated looking things where u substitution fails. Okay. So if you have anything that looks like this, 1 over a squared plus u squared, this is going to be your inverse, your antiderivative. It's going to be inverse tangent. And anything that looks like this is going to be, your antiderivative is going to be secant inverse. Okay? But pay attention. You're going to have to memorize your a's and u's, where they go. Okay? Okay, so like I said, I'm going to do a proof of one of these in the next video. So pay attention.